Okay, question 3. In this question, we are asked to find the force P that will keep this structure in balance. So first things first, assign the coordinates, which they have already done so for us. They've assigned X for P and H1 for the weight W. Keep in mind that W passes through the center point of this uniform rod. So let us go ahead and start writing the PVD formula, which states that dW, the works done, is equal to 0. Now, who are the works done? We have P multiplied by delta X and W multiplied by delta H. Notice that P is in the opposite direction of delta X. See, delta X is pointing rightwards, whereas P is pointing leftwards. So if they're in opposite direction of each other, we assign this work done as negative. So negative P dx. Now what about the work done by W? If you focus on W, W points downwards, whereas its displacement, delta H1, points upwards. So again, this is a negative work done. Negative W dH1. So now, let us see if we can use the geometry to drop these infinitesimals. Now, in this question, the geometry that we're supposed to exploit here is using similar triangles. Now, let me explain. If you zoom in carefully, notice that this big triangle here is similar to this small triangle here, right? Because all the angles are the same, so they're similar. And we know that for similar triangles, the ratio of corresponding sides are equal. So who are the corresponding sides? This vertical side corresponds to this vertical side. So this height is h1, and it corresponds to this height, which is just h, equals to, now let's take another pair of corresponding sides. So I will take the hypotenuse. Now, for the big triangle, the hypotenuse is L over 2, right? Because remember, W acts through the midpoint of this uniform rod. So half of L will be L over 2. So we have L over 2. Now, what's the hypotenuse of the small triangle? So meaning to say, I'm interested in this length. See, if you focus on that small triangle here, if I draw it out, you'll notice that this vertical height is h, and this horizontal length is x. Meaning to say, if I want this, I can use the Pythagoras theorem to state that this is x squared plus h squared, right? So this, I'll fill it into here. All right, so let me recap what we're doing. So we notice a pair of similar triangles, and we know that for similar triangles, the ratio of corresponding sides are equal. So I take the ratio of the vertical height, this, and equate it to the ratio of the hypotenuse, this, L over 2, and the smaller hypotenuse, which is square root of x squared plus h squared. So now, let us go ahead and try making h1 the subject. Okay, let's make h1 the subject. Since it's already up here, remember, our infinitesimals just now was dx and dh1. So let us make h the subject here, h1 the subject. We have, okay, if this moves over this side, we get HL over 2 multiplied by this. To get rid of this 2 over here, I can multiply 2 here and 2 down here. So this can cancel, leaving behind this. Okay? So now, if I want to express delta H1 as something multiplied by delta X, I can use the small approximate change formula. So, meaning to say, I want delta H1, it's given by dH1 dx multiplied by delta X. So we already have the expression for h1, which is obtained here. So let us fill that in. So delta h1 is equal to d dx of this giant thing. Now I'm going to convert this in a way that will help me to differentiate it. So HL over 2, I'll bring it to the front. And then this, I will change this to the power of negative half, so that it's easier to differentiate. And then don't forget your infinitesimal. So now, let us differentiate this. So I take out the constants, power bring down, power bring down, power minus 1. So this becomes minus 3 over 2 times the differentiation of the inside. So differentiating x squared, we have 2x. Let's simplify. So this half can cancel with this 2, and that's it. So we say that this is HL x 2 times x squared plus h squared minus 3 over 2. So let me check if my work is right. HL over 2, I put it here, x I put it to the top, and then this I bring it down to the bottom, and there's a negative here, delta x. Okay? So now we can substitute this into our PVD formula. So our PVD, earlier, remember it was this, then it became this. Oh wait, this is x. So we are going to substitute this dh1 into here. If we do that, we get, so this is minus HLX 2x squared plus h squared. Oops, I don't need this negative anymore. 3 over 2 is to 0. Don't forget my dx, right? So now both these terms have the infinitesimal, which is delta x. See, this has delta x, this has delta x, so I can drop it. Drop this here, drop this here. Okay. Negative times negative should give me positive. So this becomes positive. And then here, this is negative p. So if I move it over, it becomes positive p. And then, oh, I forgot my w here. So this is supposed to be a w here. W, w. Now let me check if this answer is correct. Yes, WHLX 2 times this. Okay, so this is the answer. Okay? Yeah, I'm sorry I made a careless mistake. I accidentally forgot my W here earlier. So this is it. Where did my OneNote go? Okay. If you found this video helpful, please support me on Coffee. Thank you.